Here are the solutions to the section 1.5 activity. First question says, using a graph or a table of values, answer the questions that follow. Okay, so here we want to investigate the limit as x approaches 2 from both the left and the right of 1 over x minus 2. So drawn in red here, let me make sure our colors are matching. I have graphed the function f of x equals 1 over x minus 2. I'm a huge proponent of being able to mentally visualize these graphs and evaluate these limits really quickly without having to write down a table of values. So there's the graph for 1 over x minus 2. Make sure you're able to plug some points and recreate that graph, or think about how you would recreate that graph maybe without a graphing device so that you have a mental picture of that graph. Okay, so the first question says, what's happening as x is approaching 2 from the left? Okay, so that would be something like starting at 0 and approaching 2 in this direction. So there is x approaches 2 from the left. What's happening to the outputs of the function? Well, at 0, we're at negative 1/2, and as we approach 2 from the left, those outputs are moving in this direction, and in fact, they're getting larger and larger in a negative fashion. So this limit is negative infinity. Next question is, what's happening as we approach 2 from the right? Okay, that would be something like starting at 4 and then getting closer and closer to 2 in this direction. So there is x approaches 2 from the right. And what's happening to our outputs? Well, at 4, we're at positive 1/2, and then as we approach 2, our outputs are moving up in this direction. And here our outputs are y's, or our f of x's, are approaching infinity. And so this limit is infinity. Okay, what can we say then about the limit as x approaches 2 of x minus 2? Well, what do we know? We've investigated and determined what the limit is as x approaches 2 from the left of 1 over x minus 2. We've also seen what the limit as x approaches 2 from the right of 1 over x minus 2. And what did we see about those things? Well, we saw that they're certainly not equal. One is negative infinity, one is positive infinity. So we say that the limit as x approaches 2 of 1 over x minus 2 does not exist. It doesn't exist because the left and right hand limits are different. And again, this is a situation where this function has a vertical asymptote, and that vertical asymptote is the line x equals 2. Okay, a couple more questions. Number 2 says, write and graph a function f of x such that the limit as x approaches 1 of f of x is equal to infinity. Okay, I've drawn a picture of such a thing, and now our job is to think about what that might look like if we tried to write it down. Okay, so we want to write down the function f of x. And we've seen in a couple examples now that this vertical asymptote occurs when we have a 0 in the denominator. And we want that 0 in the denominator to occur when x equals 1. So that's going to mean we need a factor of x minus 1 in the denominator. If we went ahead and made the numerator 1, our picture would look very similar to the one up here. It would just be shifted over with our asymptote at x equals 1 instead of x equals 2. Okay, but that's not what we want, right? Because now if we put 0 in for x, our output is negative, and we want all of our outputs to be positive. One way we can change that is by taking the absolute value of x minus 1, but the slightly easier way to change that is the other function that makes everything positive is squaring. Well, the 1 is already positive, so if we just square the denominator, it makes everything positive, and we get the picture that is on the left. So there's a function with limit as x approaches 1 being equal to infinity. Okay, another similar question, but here we want to change the game, and we want the limit to be negative infinity. Okay, so let's start building this function, g of x. Again, we know that the asymptote's going to occur when we have a 0 in the denominator. We want that 0 to occur at negative 1. So we need a factor of x plus 1 in the denominator. And again, we can put any constant in the numerator. Let's choose 1. It's pretty simple. And let's build off from what we had before. If we did this, it wouldn't quite match the picture I have drawn. Everything would be reflected above the x-axis. How do we reflect everything back down below the x-axis? How do we make all of the outputs of this function negative? Well, the one term that we could easily make negative all the time is the numerator. And there it is. So g of x equals negative 1 over x plus 1 squared is the picture on the left and has limit as x approaches negative 1 of negative infinity. There's lots of different answers to those two questions. Depending on what constant you put in the numerator, you could change the denominators too ever so slightly, but those are the most efficient ways to build those functions.